buildings, they're all around us. Do you ever wonder how they're made? This video will instruct you on how concrete foundations are cast and how I-beams are manufactured. We'll start off with concrete casting. Buildings are made on concrete foundations. Concrete is a mixture of cement, sand and gravel. Once they are mixed together, they solidify over time, creating a structurally sound, flat surface ready to build on. The normal formula used to make concrete is 1 part cement, 2 parts sand and 5 part gravel. This can vary depending on the strength the concrete needs to be, but this is normally used for industrial buildings. So there's a cement, and a sand, the concrete mixture is then sort of mixed up by a cement mixer that varies in sizes depending on the size of the job, but obviously I don't have a cement mixer, not for some flour anyway, so it's like mixed up and then little bits of water added at a time to make a solid and a sort of molten solution. The amount of water added is usually the same as like an equal amount to the 1 part cement. To cast the concrete, first builders must dig a trench where the concrete can be filled in, just left to solidify. I'm using bread to represent the soil with a pre-dug out trench. The concrete cannot be poured straight into the trench. It has to be surrounded by wood first, which is represented by these little wafers. They simply go on the sides of the trench and are sometimes held up by struts that reach across the trench. More concrete is then added until it reaches the top of your wooden walls either side. To add structural support to the concrete, steel beams are added inside the concrete as it's being cast. To get the concrete flat on the top, you then roll a large flat blade over the top and the concrete will set in this shape, so the builders want to make sure they get it completely level. We go to Menas, who's going to teach you about I-beam manufacturing.
I-beams are made of structural steel but could also be formed from other materials. There are 2 standard I-beam forms, which is, one of them is rolled I-beam, which is formed by hot rolling, cold rolling or extrusion depending on the material. Then there's plate grinder, formed by welding or occasionally bolting or riveting plates. Hot rolling is basically a metal process that happens above recrystallization temperature of the material, and then after the grains deform during processing, they recrystallize, which means the crystals that have axes of approximately the same length, and that can be achieved by heat treating, annealing and normalizing. For example, you could heat a sword and then shape it repetitively until you get the form and shape you want it to be in. MicroStructure is basically small-scale structure of material which prevents metal from work hardening. Cold rolling. Cold rolling is basically, it occurs when metal below its recrystallization temperature, usually at room temperature, increases the strength through strain hardening up to 20%. It also improves the surface finish and holds tighter tolerances. Cold rolling cannot reduce the thickness of a workpiece as much as hot rolling in a single pass. Extrusion is the third one, and it basically means used to create objects of a fixed cross-sectional profile. a material is pushed through a die of a desired cross-section. The two main advantages of this process over other manufacturing processes are its ability, because it's very complex and the work materials are brittle, because the material only encounters compressive and shear stresses. It also forms parts with an excellent surface finish. Extrusion can be continuous, so producing long material, or semi-continuous, which means producing many pieces. The extrusion process can be done with the material hot or cold. Commonly extruded materials include metals, polymers, ceramics, concrete, Play-Doh, and foodstuff as well. The products of extrusion are generally called extrudates. Plywood I Beams. So it's an environmentally friendly alternative to steel I Beams. Plywood can be used instead. So this is obviously using a more renewable material than steel. Although it's likely not to be strong as steel, it is considerably strong and hard-wearing, but may need to be treated to prevent any potential damage from outside sources such as water or pests.
Our first example of I-beam fixing is where a webbed I-beam is attached to a I-beam with a flange. The flange is welded on after the I-beam has been made. These two are joined via a series of bolts, as shown here. Our second method for joining these two I-beams together is to use a bracket in conjunction with the bolts. Two standard I-beams are moved together, where the bracket is then fixed onto both I-beams at a corner point and fixed in with these bolts, as shown here. Welding could also be added later on in these areas in order to make the joint even stronger. In this example, we're fixing the I-beam to the floor. As alternatively joining two I-beams together, we'll be fixing this I-beam to the concrete foundation, as seen here. However, with this concrete foundation, an I-beam would normally be situated within the floor, which would have pre-cut holes to allow these bolts to be fitted in through this exterior I-beam, through the floor, and into the other I-beam, as is shown here.